What happens here? What is this? What exactly is this picture?
I guess there's a drop of water falling and all the other particles of molecules of water are being moved.
So what do we call these? These are called ripples. Okay.
Yeah.
So if you throw a stone, or like you said, if there's a drop of water which is falling on water, then such ripples are created in the pond or lake or a glass of water or whatever it is, right? Okay. Which means these ripples are small waves. And what are these waves carrying with them?
Energy.
These waves are carrying energy with them. So from where do they originate? From the point where the pebble hit the water, and from there they start originating, and they are carrying that across the pond or across the till wherever that energy is able to last, right? Because of that, there is a wave effect, and that wave effect is going to go up down in an up down motion in water, right? Okay. Now this same thing which is happening here, this you are able to see. Now the same thing happens in sound, but you're not able to see that. Such waves are being created, but you're not able to see that. And it happens in light also. So sound and light both have such waves. Okay, but you're not able to see these waves because they're too tiny. Are you there, or your video stuck, frozen? Can you hear me?
Yeah, sorry, I was changing.
Okay. So exactly what you're seeing here, the same thing happens in light and sound also, just that we're not able to see it because they're too tiny for us to see. Okay. Now, I'll show you one experiment. Yes. Okay, ये क्या है? All right. Do you know what is a slinky? Right. Okay. Now the slinky is moved in. Can you see the motion of the hand? How it is being moved? Up, down, karke move kiya. All right. So when it is moved up and down, so what happens with the slinky? The slinky also takes the form of wave. All right. And then it will start. The wave motion is like a to and fro motion. Aage and piche kind of motion. Okay. And is to and fro motion ko hum kya bolte hain? That's called as the
Vibration.
Oscillation. Oscillate. One oscillation. One motion is one oscillation. Okay.
So what's vibration?
Vibration, I'll tell you what exactly. Something vibrates because of which these oscillations are being created. All right. When the oscillations are moving up and down, or then you will call it as transverse waves. So what you see on your screen is a transverse wave. Okay. Because aap kaisa movement dekh rahe ho? It is like a wave. It is going up and down like this, up and down. Okay. Now I'll show you another picture. In this picture, the motion is a little different. Still there is energy which is moving. But in this, if you see, can you see the movement? Can you see the movement here?
Yeah.
क्या movement हो रही है यहाँ पे? You push forward and backward. है ये भी to and fro, forward and backward. ठीक है? So imagine in longitudinal wala case, what you see here is there are a few children who are standing in a row. All right. You are at the end, you push the person in front of you. Okay. तो क्या होगा? वो अपनी जगह से थोड़ा हिलेगा, फिर वापस आ जाएगा अपनी जगह. But because it moved the person in front. ऐसे करते 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 समझ लो कि पूरे क्यू में every child who is behind is pushing the child in front of that person. Okay. So ऐसे कैसा एक movement होगा? But they are all coming back to their position. They're not moving from their position. Are you getting it? Okay. That kind of movement is a longitudinal movement. So now here, how do you define it? Very important. First, in a transverse movement, oscillations are right angle to the direction of travel. So do you see where is the direction of travel here?
Yeah.
Where is the direction of travel? Like this.
Yeah.
And the oscillation is at a right angle, like this, at a right angle to this. So are you getting it? But
Mhm.
in the second case, the oscillations are in the direction of the wave. All right, direction of the wave. So which means oscillations आगे पीछे ऐसे हो रहे हैं. They are not like this. They're not like this. They're not like this. कैसे किस तरह की movement है यहाँ पर? आगे पीछे वाली movement है. And that matches with the direction of travel. ठीक है? So ये एक बहुत important point है for you to note it down that in a transverse wave, what is the direction of movement and of the wave? Oscillations are at right angle to the direction of travel. Okay, and in the second case, what will I write here? Oscillations are same as or are at a same angle as the direction of travel. So do you understand the difference between the two?
Yeah.
Right? Okay. ये बहुत important है. Okay. Another thing that you see here is so transverse और इसमें आपको समझ आ गया कि movement किस तरह की है. अब example देखते हैं. Transverse waves are usually, so sound wave और light wave में ये एक बहुत major difference है. Light waves are always transverse waves. So इसका example आपको क्या लिखना होगा? What is the example for this? Example is light waves.
Light.
Right? And what is the example for transverse longitudinal waves?
Sound.
Sound waves are always longitudinal, which means आप अभी अगर बात कर रहे हो, so आपके सामने जो waves create हो रहे हैं, वो किस तरह के waves create हो रहे हैं? Sound waves तो हैं, but what kind of wave? Longitudinal waves, right? This part is clear? This part is clear? Okay, now in the longitudinal wave, so I'll just write the example here. What is the example here is, it is sound wave. So first thing that
all transversal waves travel in a vacuum?
So, sorry, say it again.
Can all transversal waves travel in vacuum?
All transverse waves travel in vacuum. So, but sound waves cannot travel in vacuum.
Because they need a medium to travel.
Because they always need a medium to travel. Okay. So that will come under the differences between light wave and sound wave. Okay. Now, do you see in the diagram, there is something called as compression and rarefaction given? Compression and rarefaction. What is that?
Compression is when all the particles are very close together, which is
very good.
Longitudinal waves. It's to pass on the energy. And rarefaction is the opposite, where particles are away from each other. Away from each other. So when there is a, so can I call this compression and rarefaction as there are two different sections in which the particles are very close to each other. That becomes a high pressure area. So for a compression, can I call that as a high pressure zone? High pressure. And rarefaction, can I call it as low pressure? Yeah. Because they are apart, the pressure kam ho gaya, particles are closer, so they are compressed, so pressure is higher. When the particles are away from each other, then it is the lower pressure, correct? So low pressure and high pressure sections in a wave, right? Clear hua yahan tak? No confusions? Yeah. All right. So can you name a few examples apart from light wave, which I'm talking about light, which means light, the visible light. Anything else that you are aware of, which is also a transverse wave, apart from light? Longitudinal wave, we have only one example, but I
I guess all kinds of vibration. Electromagnetic waves are there.
Electromagnetic waves, all of them, right? कुछ नाम बता सकते हो आप मुझे उनके? Any electromagnetic? आप घर में you have your TV, radio at home. So how does it work?
Microwaves, I guess, should be an
Microwave, yes, microwave is a kind of wave. Yeah. Radio waves, very good. So 2 examples you've already given. Perfect, very nice. All right, this part is clear. So electromagnetic waves में हम और examples क्या क्या दे सकते हैं? We can call light. मतलब when I say light, I mean visible light. You leave your phone if you're on your phone, please.
No, thanks for.
Then you said radio waves, and you said radio waves and
microwaves.
So entire electromagnetic spectrum also. Electromagnetic waves. All right. So, but for longitudinal, we have only sound wave. Okay. Now that we are into the waves so much, let's understand the various parts of a wave. Okay.
Yeah.
So let's now discuss that. Okay. Now here, there are 4 words which you always need to know. Okay. Speed, frequency, wavelength, amplitude. What are the 4 words?
Speed, frequency, what else?
I'll write it down.
Wavelength.
Speed, frequency, then wavelength and amplitude. So let's first talk about speed. So what is speed? How do you define it?
Speed is the rate at which the wave covers distance in a particular amount of time.
Speed can be simply said, it is the speed of the wave. At what speed it is moving, right? Speed of the wave. What do you think is the unit for speed of the wave?
Seconds.
Huh?
Oh, speed. Sorry, meter per second or this thing.
Meters per second is the standard unit. Standard unit would be meters per second. Okay. Next is, what is that was speed. Now next, frequency. What is frequency?
Frequency is the amount of time the wave oscillates in a second.
So whenever you are in 1 second, yes. So number of times. So how do I call it? Number of waves passing through a point in 1 second. What do I write? Number of waves passing through a point. Passing through a point in 1 second, right? What is the unit for this?
Hertz. Exactly.
Hertz. How do you represent it? Hertz. How do you represent it? H.
Capital H and Z.
Z. Perfect. Okay. So that becomes your second definition, which is very important. Next definition is about wavelength. What is wavelength?
Wavelength is, I guess, the length of a wave.
It is the length of a wave. Now, from where to where? It's the distance.
Starting point to the end.
Between any point on the wave and the equivalent point on the next wave. So, आपने जहां से भी पकड़ा wave को, उसी का equivalent होना चाहिए, ठीक है? Let's write that down.
The same x-axis.
Right. wavelength is, what is it? It's the
Of 2
distance
points
between any 2
x-axis
points.
on a horizontal line.
Distance between any 2 points on a wave, and the equivalent point on the next. Are you writing?
No, I was reading from the textbook.
And an equivalent point in the next wave. Clear? अब इसका यूनिट बताओ जरा क्या होगा?
Wavelength का, I guess this should be lambda, no? Is that for wavelength?
यूनिट पूछ रही हूँ. यूनिट क्या होगा? मीटर.
Centimeters or meters, yeah.
अगर स्पीड वाज मीटर्स पर सेकंड तो वेवलेंथ क्या होना चाहिए? डिस्टेंस क्या होना चाहिए? Meters. Okay. Now our last word for today for defining a wave is amplitude. क्या हो सकता है amplitude? What, any idea?
Amplitude is basically loudness of a wave, or how much force is
Perfect.
behind the
Perfect.
energy.
Okay, but in terms of wave, it's a distance. It's the maximum distance. Yes.
Between the center point and the top.
From the rest position. Okay.
Yeah.
Maximum distance of a point. Maximum distance a point moves from its rest position when the waves pass. Maximum. How to define it? Maximum distance from the rest position. Let's see all of this on the graph now. चलो देखो यहाँ पे स्पीड यू अंडरस्टूड क्या होगा? मीटर्स पर सेकेंड, राइट? कि अगर मैंने if in 10 seconds there are 30 waves, then what will be the speed?
In 10 seconds, 30 waves. That's meter.
Huh? What is the speed?
3 waves per
3
second.
meters per second, correct? Okay.
Oh, 1 wave is 1 meter.
3 meters per second, right? That's the speed. What are you confused with this?
Like, yeah, if a wave ka length is 1 meter, then yes.
Okay, I mean to say that if the wave is covering 30 meters, a wave is covering 30 meters in 10 seconds, then what is the speed of the wave? Ab batao.
3 meters per second.
3 meters per second. Okay. Now, all right. Do you see here now? This is one wave. One wave kahan se kahan tak bolunga main? From where to where is one wave?
Okay. So that is from, I guess, this point. Should I mark?
Yes, annotate.
Yeah. So that is point to this point.
Perfect. So that is one wave. Had I started from here, तो one wave कहाँ जाके complete होता?
Here.
Very good. Perfect. So I think wave is understood. One wave is what? Now let's talk about one wavelength. So
Yeah.
suppose my wave is from one wave. First, to get the wavelength, I need the wave. My wave is, this is one wave. Now tell me what is the wavelength?
The distance between those 2 points. So that is this point and that point. So
the distance between this point to this point, right? Suppose I take from here, then what is the equivalent point for this in this wave? यहाँ पर.
okay.
Equivalent point होगा. So the wavelength would become this to this, correct? Right? If I'm somewhere here, equivalent point will be here. This will become the wavelength. You understood what is wavelength now?
Yeah.
No confusions there?
No.
Okay. Now, next comes amplitude. I think you already told me before that this is the, if this one is the rest position and this is the distance from the rest position, the maximum distance which it is covering from the rest position, right? Okay. So this is clear. Now we come to a very important equation which is called as the wave equation. Okay. So there are certain representations which we will write down. Speed, frequency, and wavelength. Before that, I want to tell you something else. I'll first you write down speed को हम कैसे denote करेंगे. Earlier what we wrote was the unit.
Yeah.
Okay. And now what we are writing is the denotion. Okay. How do we denote it? So इसको denote करते हैं V.
Velocity.
ठीक है. Wavelength को denote करते हैं हम lambda.
Which is like a theta time.
And frequency को we will denote by f. ठीक है. अब मुझे एक चीज बताओ before you remember this formula. Speed is equal to
Distance upon time.
You know that speed is equal to distance upon time, right? Right? Acha. Now this frequency is equal to 1 upon time. Okay. So speed को मैंने ऐसे ही रखा. Speed is, this is speed, or let me just write full forms of this. This is speed, distance, upon time को मैं into 1 upon time कर सकती हूँ. कर सकती हूँ?
Yeah.
Right? Speed को हम wave में कैसे represent करते हैं?
Speed is distance into frequency.
हाँ. Speed को हम represent कैसे करते हैं? ये मैंने आपको फॉर्मूला याद कराने से पहले, वेव इक्वेशन याद कराने से पहले, हमने सिंपली स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम ना, जो फॉर्मूला हमें ऑलरेडी पता है हम वो लिख रहे हैं. स्पीड इज नथिंग बट यू रिप्रेजेंटेड विद v, राइट? व्हाट इज डिस्टेंस इन अ वेव?
Distance in a wave is lambda.
Lambda यानी wavelength, so I'll represent with lambda. And what is 1 upon time?
Frequency, which is f.
Frequency, so I'll straight away write this. So you know now this is the equation for the wave. That's called the wave equation. What is it? It's called the wave equation. What is V?
Speed or velocity.
V is the velocity or speed. What is lambda?
Wavelength.
Lambda is wavelength. Okay. And what is F?
Frequency.
And frequency और time में क्या relationship होता है?
Inverse.
Inverse relationship होता है. ठीक है? This part is clear. This what is wave equation is clear.
Yeah.
Next. Sure. Let's do this. Done?
I'm stuck on D2.
If two waves pass the flag every second, what is the frequency?
Frequency is 2 hertz. But what is part 2?
The time period.
Oh. I didn't get the question. What are we supposed to find?
If two waves pass the flag every second, okay, what is the frequency? Okay, what is the frequency? Two waves.
2 hertz.
2 hertz, okay. And what is the relationship between frequency and time?
1 upon time. So 2.
So time is equal to 1 upon f.
Half time.
So what is the time period?
The time period for one wave.
So whenever they ask you the time period, it's always wavelength पूछा तो एक wave के लिए, time period पूछा तो एक wave के लिए, okay? But frequency is in 1 second. In 1 second, there can be many waves also, right? Got the question?
Yeah.
Not such a big question. Done.
Yeah, man, this thing. G.
Shamik, हो गया बेटा? It's not such a big question.
Yeah, and
Tell me your answers, please.
Yeah, okay. So A is
Are these transverse or longitudinal waves?
transverse.
How?
Wavy.
But will it? It's the wave traveling across water, bol raha hai. So water waves are.
Transverse, I think.
But will they happen without a medium?
No.
No. So they're a combination. Okay. Water waves are always a combination right now.
So what do I write? Transverse and
Combination of both. Okay. Next question. What is the wavelength of what of the waves? Wavelength kitni hai? How much is the wavelength?
One second. Why are they both? Because even transverse waves can travel with medium and without medium. So can the answer just be not can be just transverse?
Okay. Okay. Okay, let me just write this down. Let me check.
Okay.
What is the wavelength of the waves?
2 meters.
2 meters. Okay, good. Then what is the amplitude of the wave?
1 meter. What? 1. Yeah, I guess amplitude ka this thing is meter only.
Meter to theek hai, but how is it 1 meter? 2 blocks is this. So which means yahan par 2 blocks is this. Right? So but mera rest position agar ye hai, so how much is the wave movement? Amplitude?
Oh yeah, half a meter. Right.
Kitna hoga?
Half.
So can I write 0.5?
Yeah.
Then if 2 waves pass the flag every second, what is the frequency?
2 hertz.
2 hertz. And second part?
0.5 seconds.
0.5
Second.
seconds. E. What is the wave equation to calculate the speed of the waves in A?
4 meters per second. So its velocity is equal to lambda into frequency. So that's 2 into 2, which is 4.
Velocity is equal to lambda into frequency. So next.
So that is 2 into 2, which is giving you 4 as the answer.
2 is the wavelength. 2 is the wavelength, right?
Yeah.
Frequency is also 2. So 2 into 2, which is 4 meters per second.
Yeah.
What is the wavelength of the waves in the diagram B?
Which question? 3 meters. 4 meters.
One, 2, 3, and 4. 4 meters. So F is 4. Okay. If the waves of B have the same speed as those of A, what is their frequency?
1.
How do you do it?
Velocity is equal to lambda into frequency. So our velocity is 4. 4 is equal to 4 into frequency. So frequency will be 4 upon 4, which is 1.
Which is 1 watt?
Hertz.
Okay. So this part is understood clearly.
Yeah.
All right. So next topic, that is a very important topic. Okay. I'll start with the topic now, but we won't be able to finish it. Okay. Now, this topic is called as the wave effect. Okay. Now, do you see some diagram on your screen?
Yeah.
Now this diagram, what you see on the screen is called as a ripple tank. What is it?
Ripple tank.
Ripple tank. क्या काम है ripple tank का? Ripple tank starts creating small tiny ripples, which means tiny waves. Okay? And these, so obviously these waves will be created in water. Okay? And then various obstacles are kept in that water, so that somebody can observe what all is happening, what changes does just to understand the property of the wave, to understand what effect happens on the wave. There is ripples created, obstacles put, and somebody observes these. Okay, so in this case, do you see there are on the screen, if you can see, there is a motor, right? Here, if you can see, there is a motor here.
Yeah.
क्या काम है मोटर का?
It produces the ripples.
That motor is there to produce the ripples. Just below that, if you see, it's written vibrating block to produce ripples. Okay, so there is a motor that is going to vibrate this block, and this block is kept in what? It's kept in the tank in which there is water. So क्या होगा अगर मोटर रहेगा, वो वाइब्रेट करेगा, और वाइब्रेटिंग ब्लॉक अगर वाइब्रेट करेगा, so then it will create ripples in that water, correct? Right? Okay. And then do you see there is a person who's observing something?
Yeah.
Right? What is he observing? Do you see there are ripples, and niche ek wave shadow on the screen is observed? So this person is observing those wave shadows. Okay? What is the person observing through? Through a spinning disc, which is called as stroboscope. Okay? And that spinning disc is kind of taking pictures, kind of sort of, to analyze. So it freezes the motion for the person. Freeze kar deta hai motion. So you are able to observe that motion properly. Point is clear? Ye kya karne wala hai? Now in our next class, we are going to go further, and ye jo shadow niche ban raha hai, jo ki through stroboscope is being observed, we are going to analyze various shadows. So basically the waves which are being created, okay, which we are going to talk about in next class. So what will happen if reflection occurs? What will happen if refraction occurs? And diffraction. In तीनों topics पे past papers में भरे हुए हैं questions on this topic. So this topic is very important. ठीक है? Which we are going to talk about in next class. Okay. I'm going to stop here, stopping the recording.